cheap shit. Oh, this is lovely. I'm not building a generator at all. I'm building a three-phase unit. That's what I'm doing. take these guys, and we're going to go inside of here like that, all the way around, north, south, north, south, north, south, north, south. And then I'm going to rewind this to a three-phase DC motor, and we are going to make a pretty bad ace three-phase motor out of this. This is a stator out of a different stator rotor out of a different ceiling fan. The one that I took off of here obviously was like this, but in order to make this casing, I'm going to take these bearings off and put them on here, and this makes this such a tight fit that it's going to work perfect. You don't have to do anything else but put your magnets on the inside and put it back together, make a three-phase winding, and use a controller, and this thing ought to be pretty superb. So we are going to see. I was going to build a wind turbine out of this, but the way that fits in there is so perfect, I need to build a motor out of this. I could build a pretty good turbine out of this too, but I'm building an ultralight, and this might just work for one of my prop motors. I think that's what I'm going to do. That would be a pretty badass motor. And I'm going to put a neodymium magnet on this part of the case as well as this part, and I've got to get this out. So let's do that now. Where's my flat? That was easy. This, I believe, is the rotor, that being the stator, original stator. So originally this went like this. Now if you want to build a wind turbine out of this, you simply use the windings that are already here on this one or that one, it doesn't matter. Use the windings that are already there. It'll be two separate phases of coils. So you have one set of coils here and then another set here. So what I do is I run them in series. So basically I take two wires, one from each coil, and put them together, and then I take the two wires left over, one coming from each coil, and run it as one single phase. So you get more output out of it without having to combine the phases later. It just automatically comes out as one phase, and you're combining the voltage here and the voltage here in one spin. So then you would take your casing, you put your magnets aligned with each pole, north, south, exactly how the rotor or the coils are on here. So you would go through and mark it out: north, south, north, south, north, south, north, south, north, south. And then you go inside your case here and you mark out where your coils are, which is exactly, but I'm going to do a little different because I'm doing a three-phase, so I'm going to have more magnets than I have coils. But with a generator, you want the same amount of magnets as you do coils, and we're going to go off this outer ring with the same amount of coils on this one, so everything will line up. You know what I mean? So just line it up exactly. Oh, excuse me. Line it up directly on that line in the middle of each coil. So you go through and mark it 1, 2, 3, you know what I mean? And mark each one in between the coils, and then go back and put your magnets and glue them to this thing. You know, bring them up as close to the edge as you can and glue them north, south, north, south, north, south. Then you take this thing and you do the same thing, and you go north, south, and then you put them together, and you got to line up your magnets whenever you put it together. So there's a magnet here and a magnet here, and make sure the poles are the same. So you want to make sure you have a north magnet here and a north magnet there. So it goes north, south, and then once you do that and you put this back together, you have yourself a very good generator. I mean, these things put out quite a bit of power. you're limited to wattage because of the size of windings. So say if it's a 100-watt motor, you know, you've got 2 sets of windings, so technically you can get 200 watts out of it. Excuse me. This is a 60, well, not this one. This is a 60-watt motor. So between the 2 coils, I should be able to get 120 watts of power at it at the RPMs it's rated for. Now you spin it higher than that RPMs, I don't know. No, I'm pretty sure that's just about the max you're going to get out. Especially using it as a wind turbine, it's not going to spin any faster than it would if this had some serious wind on it. But let's just go by that. I mean, you might be able to get more out of it under good wind conditions, but let's just go by, you know, the rating of the motor. I believe it's on the casing here. Okay, here we go. So you can see this right here. It tells you the light, and it tells you the fan, and it says the fan is 60 watts. Okay, so when the fan is saying it's 60 watts on here, that means you know you can get 120 watts out of this turbine. So it says 220 watts total, but 160 of that is for the light that goes on the ceiling fan. So we don't want to add up what's on the light because that's irrelevant. All we need to know is about the ceiling fan, and it says on here for the motor 60 watts. Okay, so that's a little food for thought on how to know what kind of rating you're getting. So when you go to Goodwill or wherever and you look for a ceiling fan, that's where I got all mine. I've got 15 of them. I just pick them up anytime I find them. You go to Goodwill and you get them $5-10, and you find the ones on the shelf that have the highest wattage rating, and those are the ones you want. So if you find one that's got a 300 watt rating, a highly inefficient ceiling fan, then that's good, because that's going to put out the most power. So that's what you need to look for when you go buy your used ceiling fans. Just keep that in mind. But instead of, I was going to make this a wind turbine video, but I just changed my mind, and I'm now going to make this a 3-phase motor. So the only problem that I'm going to run into is I've got to rewire, recoil, redo the windings on here, and also I don't have the right number of coils around here. So what I'm going to have to do, there's going to be 2 spots where basically, no, because I'm going to go, right now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I only need 15 in order to do 5 times 3, that's 15. So at one point, one of these coils that I'm going to have to do is going to have to go and extend over 2 sections, or I'll probably go 1 coil and go 3 holes, and then the next hole will go 3 holes to kind of space it out. But basically I'm going to have to do, instead of 16 coils, I got to have 15 around here. So I'm going to have to change up a little bit how one area of the coils are, but I don't think it's going to be a big deal as long as I, you know, space out as much as I can. The motor should still run fine. So, and I've seen it done. So yeah, it will run fine. I know it will. So I've got to get all these windings off and pick what wire I'm going to put on here, which I'm going to go with a fairly thick gauge, or I'm going to do multiple strands of a smaller gauge. I'm going to rewire this one phase right here, and then I'm going to go right back over here, 2 phase. So basically it's going to go 1 2 3 1 2 3 1 2 3, and it's going to make this, and I'm going to take that one all the way out, and oh, I could leave it there and it might act as a generator while the motor's running. Never thought about that. It might put out some power while the motor's being powered up. Extra weight on it though, I really don't need it. I could do a secondary winding there, like they do for aircraft electric motors. They do a secondary winding, so that way if you ever, for some reason, one winding fails in the air. Oh, sorry, I got the yawns thing. So in case for some reason this winding is to fail, you could switch over and put your power to these windings and continue to run the motor. in the air, in case for some reason something happens and you burn up this wire. You know, you can switch over as a backup. So I might do that, because I'm wanting to use this for an ultralight aircraft. I might I got a hang glider that I built, and I'm going to use this for a powered hang glider. I'm going to try. I don't know. I might have to have 4 of these, but still, that's 4 $10 ceiling fans and some magnets is a lot cheaper than buying the $300 and $400 for RC, you know, motor that's not even this big. So I don't even know what they would charge for one. I mean, they don't really market the ones for homemade ultralights. Buy a motor for your homemade ultralight. You don't really find that. So I'm going to try and make an electric ultralight is my plan. And I plan to use, I've got a ton of these. So I've got a bunch of old Makita batteries, and I'm just going to take all of them and make one giant battery pack. Probably got 100 of these, if not. No, I got more than that. I might have 200 of these. I mean, that's what powers the Tesla car. A lot more than that, I think, but I've got 200 of them, so I'm going to test each one, take them all apart, test each one individually, and make a giant battery bank, and then use this to power this motor. I've got a Benjamin Vetter VESC. It's a 3-phase ESC. Here, I'll grab it. I'll show it to you. Yeah, this guy. This is a pretty powerful ESC for a 3-phase motor. You can program it literally to any freaking thing you want. It'll even run a single-phase brush motor. It'll run anything. It's a really powerful ESC. It's well made. This is a legitimate Benjamin Vetter. There's a lot of copies, but this is a legitimate, actual. I mean, it's not made by him because he sold well, he don't make them. He allows other companies to make them. There's a whole thing about it. But if you look right here, this is my ESC, and it is pretty sweet. I don't know if you can see that. It says Vetter. Yeah, it says Vetter up there. It's a Benjamin Vetter VESC. I'll show you this side. I mean, it's got all kind of plugins on it. I mean, this thing is legit. I've ran multiple motors on it. I can hook it up to my laptop. It'll auto detect what motor you have hooked up to it. If you're lucky, you just kind of got to tell it a few things, like what size motor it is, whether it's an in-runner or an out-runner, and then all of a sudden it'll start going and spinning the motor up until it calculates it, and then it'll say, bam, you're done, and then you freaking turn it up, and it works. I mean, it's a really, and it goes up to 60 volts. So it's a 60 volt ESC. So these motors technically should run on high voltage and high frequency, and this is the highest voltage ESC that I was able to find, so that's why I bought it. But it actually is a really good ESC. Not what I really wanted. I mean, I want something that's going to run 120 volts per phase, you know, simultaneously, but I ain't been able to afford or find that yet. So right now this is what I've got, but it is a really good ESC. So shout out to Benjamin Vetter, he did a great job on this. Those ESCs are actually most commonly used in electric skateboards, by the way. That's what mostly everybody uses them for. That's what he kind of designed them for, because he was making a skateboard. And he said that there wasn't a good enough ESC out there. So, anyways, back to the subject. If you want to make a wind turbine, you take your cylinder pin apart, put your magnets around there. Super easy. I just finished one, and I've got it on the roof. It's a wind turbine on the roof right now. I'll walk up there and show it while it's hanging, and I'll walk up there and show it to you. But it has really good output power. I mean, I take this thing, and just to show an example of what kind of output you get, I wish I had it down here because I would put the voltmeter up to it. But I'll show you this one. If you stay tuned for the next video, you get to see what the output of this one is. Even though it's going to be a motor, I'll still show you the output. But literally, you take that one that I'm about to show you, and you do this. 42 volts, guys. 42 volts. And the wattage is not bad. The wattage is impressive. So, and it's a little bit bigger than those. So let me walk out here and I'll show you. Beep, 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 beep. I don't even see it. It's hanging up there. Oh no, you can't see it. Let's see what we can do here. How about that? Nope. Okay, let me get a flashlight. 1 second, guys. I'm gonna go get you a flashlight so we can see the windmill I got up there. Cool little design. Gotcha. Got the serious flashlight here. Here we go. Voila. There she is. I don't know if you can see that, but there is, in fact, a ceiling fan up there. Hold on, let me get situated here so I can zoom in. Ta-da, ceiling fan. And that's my wind turbine. It's got, just like I did the one that I just showed you, where I have a the casing and the stator, rotor, whatever, they're real tight together. I did the same thing. So basically I took a smaller ceiling fan and a bigger ceiling fan, and then I took the casing from the smaller one and put the bigger stator in there, and made it where the magnets are real tight to the stator, like this. You know what I mean? So normally with a ceiling fan, it's got to fit. Normally it's got to fit this in between the case there, and that's, you know, and then you got to put stack magnets and bring them out. But I happen to have multiple ceiling fans, and I just tried it, and turns out if you get a bigger one and put it in this small casing, it really closes that gap. I mean, and so when you put a neodymium magnet in between there, that thing's going to be strong. I mean, you can really feel the magnets when you turn that thing. So unfortunately, I shouldn't have done that with my wind turbine, because I should have just used the good old ceramics, because they have plenty of good power when I use these ceramics, and I stack them and I put them in there. But I went and thought I was going to do better by doing that. But the startup, in order to get that wind turbine going, I mean, it's got to have some serious wind to it. I mean, it's really hard to get it started. Once it's started, that thing will turn, and it'll keep turning with just the slightest breeze. But it don't do you no good if you can't ever get it started. So unfortunately, I'm going to be taking that down and redoing it, because it barely ever turns, because I don't have high enough wind gusts around here to really get it going. But you know, the blade design that I did, I'm happy with that. So I mean, you go up there and just bump it to get it turning, and you can have the slightest bit of breeze, and that thing will just spin and spin and spin and spin. And the output is insane on these ceiling fans. The output's really well. So you get you a bridge rectifier, and you step it down, and get you your 14 volts, DC out of there with a step down or a charge controller. And I'm talking, it will charge the crap out of some batteries. It'll do good, real good. I had 6 truck batteries running my shop, and they worked real well with 2 windmills. So anyways, I hope you like this video. If you want to like and subscribe, you'll get to see all these projects complete. This is going to be a part 1 of my, I guess now it's going to be a 3-phase brushless DC aircraft motor. And we'll make a little generator out of this for fun, with a different casing. I've got another casing around here, so I'll find something else, because I'm using this casing for this one. But don't forget, like and subscribe. Check me out. We're going to be doing a lot of cool projects. I got a go-kart that I'm building with a starter motor, and I'm also going to be doing some cool things with those coils, some toroidal coils and stuff like that. I rewired a little VCR motor. Oh, that's right. My next video is going to be where to find the brushless DC motors in the VCR, because a lot of people are not using the second one. I don't think everybody knows that there's a second VCR motor in there. So I'm going to do that video here very soon. I'll show you my little VCR motor that I rewired here, if I can get it out. Find the dang thing. Where are you at? Hold on. Sorry, probably making you guys sick. Maybe I'll edit this out. Okay. Here we go. Bam. So this was a little VCR motor. It had really, really tiny wires on it. But I went through, took them all out, and now I'm putting Fat Daddy wires on there just to see what the heck it'll do. Just playing, experimenting. And unfortunately, I used wires from a transformer, and they don't have the right coating on them. And I wrapped them super tight, and of course they are all three wires. No, just one. Just one. One of them is shorted out to the stator. So I've got to take it all back off and do it again. Bummer. But this time I'm going to use actual wire that came from a motor that is the right kind of wire, that has the right coating on it, that's a lot tougher, and make sure I don't short these things out to the stator this time. It ran great for about 5 minutes, and it had some it had some power, and then all of a sudden it goes and starts getting hot, and I tested it, and turns out it's shorting out to the stator somewhere. So I'm going to redo this guy, so that's why I didn't do a video on this yet. But anyway, can you see? Where is it at? Come on, focus. Focus. Anyways, ought to make a really cool little powerful motor when I get it done. It'll look just like this, just with the right wire. But don't forget, hit that like button. Holla.